Hi guys, what is up? We're from 11 Charles Darwin, and now we're going to talk about what Gay-Lussac's law is. So stay tuned! First off, what is Gay-Lussac's law? Or also called the Gay-Lussac's law of pressure temperature, or just simply the pressure law. A French chemist named Joseph Gay-Lussac discovered that the pressure of a given mass of a gas varies directly with the absolute temperature of the gas when the volume is kept constant. His experiment's results showed the relationship between the pressure and the temperature of the gas at a constant volume. And now, we have Mr. Quadra to explain further what Gay-Lussac's law is.
Very similar to Charles' law, as Gay-Lussac said that he used some unpublished data by Jacques Charles. The main difference of the two laws is that in Charles' law, the container is flexible, whereas in Gay-Lussac law, the container is just a rigid. This law holds true because temperature is a measure of the average of kinetic energy of a substance. Its particles collide with the container walls more rapidly, thereby exerting increased pressure. Pressure is directly proportional to temperature.
Hello, I am Kathleen Marco, and I'll be continuing this video, starting with the formula. Where the formula can be written as P1 over T1 is equals to P2 over T2. Where P1 is the initial pressure, T1 is the initial temperature, P2 is the final pressure, and T2, which is the final temperature. This formula is used when comparing the temperature and pressure of the same substance. But what if there is a missing variable? So let's have an example problem. A gas in a sealed container has a pressure of 125 kilopascal at a temperature of 30 degrees Celsius. If the pressure inside the container is increased to 201 kilopascal, what is the new temperature? So let's look at our givens. Our P1 is 125 kilopascal. Our T1 is 30 degrees Celsius, and we need to convert it into Kelvin, which will turn our 30 degrees Celsius into 303 Kelvin. Our P2 is 201 kilopascals. So our missing variable is T2, which is the final temperature. So let's find this final temperature. We can write our formula as T2 is equals to T1 times P2 over P1. So let's substitute our values. So T2 is equals to 303 Kelvin times 201 kilopascal over 125 kilopascal. So our T2 is equals to 487 Kelvin. That is our final temperature. So that's how you can find the final temperature. So let's move on to the experiments. So I have here all the materials and the setup that I need for this simple experiment to clearly show you and demonstrate how Gay-Lussac's law works. So I have here a glass beaker, a candle that is lit, and colored water so you can see it better. So once I put the jar on top of the candle and the water, you can clearly see the difference of the levels of water. It is shown here that because of the candle, the temperature increased inside the jar, making the pressure also increase, in which the water gets pulled in because of the higher pressure inside the jar. So in conclusion, the higher the temperature gets, the higher the pressure is, and the water automatically flows right to the higher pressure. And this experiment clearly shows that pressure is directly proportional to temperature. That is all for this experiment portion of this video. Now let's have Miss Ibo for the examples of Gay-Lussac's law in real life.
Some real-life examples of Gay-Lussac's law. Number 1. Pressure cooker. As the temperature of the liquid water inside the pressure cooker increases, water vapor is then produced. The pressure of all the water vapor keeps on increasing, which results in food getting cooked much faster and meat getting more tender. Number 2. Aerosol cans. When aerosol cans are heated, the gas inside the container exerts more pressure, and when the container cannot hold the amount any longer, it tends to explode. Number 3. Bullets and cannons. Bullets and cannons are based on these principles. Gas superheated by the burning of gunpowder is trapped behind the bullet and expands until the bullet leaves the barrel. And that's all.
Hi guys, it's me again and we're here for some trivias! First, did you know that it is seen that the Gay-Lussac's work directly influenced Amadeo Avogadro in forming the Avogadro's law? Second, did you know that there is a gas law called combined gas law wherein it combines the three gas laws, the Charles law, the Boyle's law, and the Gay-Lussac's law? Right here you can clearly see that the Gay-Lussac's formula is within the combined gas laws formula. The P subscript 1, V subscript 1 over T subscript 1 is equals to P subscript 2, V subscript 2, and T subscript 2.
Thank you all so much for watching this video, and I hope you've learned a lot about the key concepts of Gay-Lussac's law. That's all. Bye!